All right, so let's continue with number 3. So it says a 4 meter by 4 meter dance floor is going to be enlarged. A uniform strip is to be added to each side of the dance floor. If the area of the new floor is 25 meters squared, find the width of the strip that has been added. Okay, so again, let's draw a picture. All right, so we're starting off with a square dance floor. Draw your best square, probably gonna be better than mine, and label what you know. You know that this is 4 meters. So is this, all the sides are going to be 4 meters, okay? Now, actually, I want to go back. Erase that, and this. I'll put them on the inside, and you'll see why in a minute. You'll put those dimensions on the inside. All right, so it says a uniform strip is to be added to each side of the dance floor. So basically, you are getting all sides are adding the same amount to each side. So this square essentially is just going to get bigger on all 4 sides. So it's going to look something like this. Okay, it's now just a bigger square. So that square started as 4, but that 4 had an X added to the side. A uniform strip. Remember, we don't know what that strip is. Since we don't know what it is, we will use a variable, right, to hold the place of the width of that strip until we can actually figure out what that width is. This is going to be X, so we're adding X to that side. We're adding the same amount. Uniform means the same to all 4 sides, and I'm adding an X to this side. Hopefully your picture is a little bit better than mine. All right, but that's a uniform width being added to the dance floor to make it bigger. The area of the new floor is 25 meters squared. Okay, so the new area is that. All right, so we now have a bigger dance floor that's 25 meters squared. So find the width of the strip that has been added. All right, so how are we going to go about doing that? Well, we have to set up an equation. All right, reminder that we're talking about a square here. Finding the area of the square. Why are we doing that? Because they're giving us the area of the new dance floor. The area is length times width. Just as it is with a rectangle or a rectangle square. Same way to find, except they just happen to be the same 2 sides. All right, so we know what the area is. We know it's 25. We knew what the old length was, but we don't know what the new length was as a number. We do know what it is as an expression. So if I started with 4, all right, and to each side I added an x, how would I write that in expression? Well, how many x's did I add to that 4? I added 2 of them, right? So if I wanted to write that as an expression, wouldn't it just be starting with 4 for the length, and then I added 2 x's to it? All right, add x on each side of it. What about the width? Well, because it's a square, isn't the width the same thing? I started with a dimension of 4, and I added an x to both sides. All right, so my new width is the same expression. All right, so I'm looking at 4 plus 2x, 4 plus 2x. All right, now again, we're in the same situation where, okay, now we've set everything up. We have some issues with, I have to simplify this side. 25 is on this side, it should be 0 on that side, so there's some things I have to go about doing. All right, first thing I'm going to do is simplify on the right side. I'm going to start by distributing. So I get 16. 4 times 2x is 8x. 2x times 4 is 8x. 2x times 2x is 4x squared. All right, and on this side I still have 25. Rearranging and rewriting, having simplified on this side, when I combine those, gives me a 4x squared plus 8x plus 8x is 16x plus 16. Okay, over we have 25. Need to make it equal to 0, so I subtract 25 from this, and I am left with 0 equals 4x squared plus 16x. 16 minus 25 is 9. Okay, negative 9. So there I am. All right. So I'm looking at something like that that I'm going to have to go through and factor. All right, so now I'm going to rewrite it up here. So to go about factoring something like this, where I have a is greater than 1, all right, I have to start, remember, when I have this situation, I got to multiply these two together. There's no GCF here, so I move right into multiplying those two together. I get negative 36, okay? Negative 36, what are factors of that add up to 16? And I'm going to split this up into 4 terms so I can go about grouping. So what are those two numbers? All right, so the two factors of negative 36 that add up to 16, positive 18 and negative 2. Okay, I now have 4 terms, which I am able to now group together and factor something out of each term. For this one, I'm factoring out a 2x. All right, for this one, I'm factoring out a 9. All right, we were looking for these to be the same. They are. It's a good thing. So now I have my two factors. When I factor out the 2x minus 1, that comes out into the front as the GCF, leaving with that and this other one. All right, so I am left with two factors that I just need to solve. 2x minus 1, 2x plus 9, both set equal to 0. Solve this one. If I add the 1, divide 2, I'm left with. If I subtract the 9 from 0 and divide the 2, I'm left with. All right, so I have two answers. One of them makes absolutely no sense at all. I'm sure you can figure out which one that is. That would be this one, because I cannot have negative dimension. Right? I cannot add a negative width to that dance floor. In that case, I would be subtracting a width. It's not what they're telling me I'm doing. I'm adding a uniform strip to every side. So what am I adding? Okay, I am adding half a meter to all 4 sides. Okay, so when they ask me what's the width of the strip being added, in every instance here, all the way around, you are adding half a meter, right? So there we go. Right, and again, if I wanted to figure out, all right, what the new dimensions are, I would plug 1/2 in for x in all cases. So 4 plus 1/2 plus 1/2 gives me 5. My new dimensions would be 5 meters by 5 meters. Does that make sense? Sure it does, because what's 5 times 5? That's what they told me the area was, which is 25 meters squared. All right, so again, a good way to check to make sure what you are doing actually makes sense. Let's try the last one. All right, so I now have a 13-foot ladder propped up against a wall. All right, so let's draw it. I have a wall, I have a ladder propped up against that wall. As you can start to see, we already have a shape forming here. It's telling me that the distance from the top of the ladder to the ground, top of the ladder to the ground, is 7 feet longer than the distance from the base of the ladder to the bottom of the wall. The base of the ladder to the bottom of the wall, there's our ground. This dimension, top of ladder to the ground, is larger by 7. This one is plus 7. Okay? Plus 7 to what? Well, since I don't know either one of those dimensions, okay, I'm going to start by saying this dimension, I don't know. 7 is that dimension? I don't know. So just call it x. So how do I add 7 to that? Say this dimension, and it's 7 more than that. So my dimension here is x plus 7. All right, so I now have 2 dimensions. Okay, it's telling me I have a 13-foot ladder. Easy enough. I can label that ladder as being 13 feet. All right, So I have a triangle. I have a right triangle. That's assuming, obviously, that the ground and the wall meet at a right angle, which is safe enough to assume at this point. And they are telling me that I have these three dimensions, okay? And that I need to find how far from the ground is the top of the ladder. All right, so I need to basically find what x is so that I can find what x is. If I don't know what x is, I can't do x. So how do I go about doing that? Well, it is a 90-degree angle here at the base of the wall. Okay, it's a right triangle. That means with right triangles, if I know all three sides or have an expression for all three sides, we do the Pythagorean theorem. Pythagorean theorem states that one side squared plus another side squared is equal to the hypotenuse squared, which is the ladder, right? So I'm looking at a quadratic now because I got a bunch of things that are squared, which is good. So I'm going to do this math quickly. Remember that 2 there means there are 2 of them, so I'm going to multiply them together. And I will do that simplification. So x squared plus x squared 7x plus 7x plus 49 equals 169. Move it a little fast here. Stop if you need to keep up. But this is the easy math part. It's just simplifying. Okay. Now, don't have it equal to 0, so I'm going to make it equal to 0. Bring over 169. Left with 2x squared plus 14x. 49 minus 169 is a negative 120 is equal to 0. Now I have it equal to 0. I have everything simplified. My goal now is to factor. I need to know what x is equal to be able to answer this question. Okay? So first thing I always look for when factoring, I noticed it right away. All of these numbers are divisible by 2. I'm going to take that 2 out. Okay? Now that 2 I can completely ignore right now. I don't need it. It's not going to do anything for me. It doesn't have an x with it. There's nothing I need to solve there. I need to focus on what's inside here. Luckily enough, a is equal to 1, which is always a good thing because in this case it makes it easy. I just have to look at the negative 60 and find factors of that negative 60 that add up to positive 7. And those two factors are going to be positive 12, positive 12 and negative 5. All right. Now when I take those two and set them equal to 0, remember you have to have a variable to be able to solve something. This 2 doesn't have a variable. I don't have to do anything with it. It's not giving me a solution. There's no x there. I'm not solving for anything. When I solve these two, I get x equals negative 12 and x is equal to 5. Okay. Again, one of these makes absolutely no sense at all. That's the negative 12. Can't have a negative dimension. All right. So the answer for x, well, my x value here is equal to 5. Remember, just because I found x does not mean I've answered the question. Go back, read the question. The question says, how far from the ground is the top of the ladder? So right now, the only thing I've answered is that I know at least that this dimension is 5 feet. Okay, but they were looking for this dimension. All right, so what is that dimension? Simple enough. If I know that this is 5, I add 7 to it. Okay, so my dimension here is 12 feet. All right, so when they ask the question, just solving for x is not necessarily always the end of the problem. It doesn't mean you're done. You have to answer their question. Clearly it says how far from the ground is the top of the ladder. So from here to here, what's that distance? We just figured it out. It's 12 feet. All right. So that's it. 4 practice problems. This should give you a good understanding of at least the fact that you need to draw. You need to set up the quadratic equation based on the information that they give you. You solve for x, you figure out the one that makes sense, and you go with that one. All right, and then you make sure that you answer the question that they're asking. Again, just because you solved for x does not mean that you necessarily answered their question. Look back at the problem, read the question again. What is it that they were looking for? All right.